Hi guys, so today we are working on objective 5.4a. This is the introduction to logarithms. You've seen them before, but have you solved them before? Probably curious about them. So today I'm going to teach you the basics. First of all, they are really closely connected to exponential functions. In fact, they are the exponential function's evil twin, but not really evil. Okay, but they're opposites. You know how twins, you have the good twin and the evil twin, they're opposites, even though they look the same. Okay, they are opposites. So you'll be successful today when you can define a logarithmic function, including the domain and range. You can convert between logarithmic and exponential equations back and forth, and you can solve a basic logarithmic equation. And I mean basic, not trying to strain your brain today. These are the basics. So we're going to start off with some key vocabulary that will be really helpful. The first term we want to talk about is the one-to-one function. We've heard of functions before. We've talked about functions before. We know things like a function will pass the vertical line test. We know in a function for every x there is one y. That's a function. If it's a one-to-one function, not only does it pass the vertical line test, not only does it have for every x there is exactly one y, it's also got the opposite. It passes the horizontal line function, and for every y there's exactly one x. It is one-to-one. For every x there's one y, for every y there's one x. So here's our definition. A one-to-one function, first of all, has an inverse. We want to note that that's important. It has an inverse. It has a partner where if you switch every x with every y, you'll get its inverse. Okay? It will pass on a graph. It will pass the vertical and the horizontal line tests. Important. Write it down. And each x has one y, and ditto, each y has one x, therefore making it one-to-one. Okay? So what we're working on today is considered a one-to-one function. When we were working on our exponential functions, they were also one-to-one. Okay? Now let's talk about the definition here of logarithm. Our introduction. A logarithm that looks like this, log base b, so it's going to go in the sub, it's going to drop down to the basement, the base is dropped into the basement, of x is the power to which b is raised to get x. So basically, when you see a log, you're looking for an exponent of the base that will give you an x. For example, I say log base 3 of 9. If I were to ask you to solve that, let's think about it in these terms. To the power to which 3 is raised to get 9. 3 to what power is 9? There's your answer to a logarithmic expression. You're looking for the power you raise the b, the base to get the x, whatever this number is. Okay? So this is what we call a logarithm. I, of course, will give you some little tips to help you remember it. Okay? So let's take a look at the definition of a logarithmic function. We have a little typo here. I don't know how it got erased, but it did. A logarithmic function, first of all, I want to say, is the inverse of an exponential function. They are buddies, and they like to switch their x's and y's with each other. That's the definition of an inverse. X's and y's switch places. Okay, so this definition should look somewhat familiar. If our base is greater than 0 and our base is not equal to 1, I don't know where that went when I copy paste to create this note page. It disappeared. Comma, then the log function with base b is defined as, can't believe I put these notes out with that mess, as log base b of x equals y if and only if, I didn't spell if wrong. This says if and only if b raised to the y power equals x. You'll see teachers teach this to you to help you remember it in different ways. Miss Masson has a great way of doing it. She says it's a circular math, so she goes like this. So b to the y equals x. She just goes in a circle like that. Whereas I'll tell you, thank you, to take the base. See it down there? It's in the basement. It's down in the basement. I say take the base out of the basement, push it up, and these two guys, switch spots. Take the base out of the basement, and the two guys, the x's and the y's, switch spots. And this is what we call an exponential equation, right? Right? So, however you're going to remember it, you have to come up with a way to remember how to write a logarithm as an exponent, because logarithms aren't really friendly to our eyes until we train our eyes to recognize them. We are really good at recognizing exponents. We've been doing it for how long? We've been doing exponents? A long time, right? Since 6th grade, maybe? 5th grade? Long time. Okay, but this is your first try with logs. Okay, so let's take a look at these two. These are equivalents. And this is what I'm going to call my conversion chart. Here's where I'm going to pick up my colors. Yeah. Oh, domain and range. We need to put it in. Thank you. I forgot. I keep forgetting to do that. Okay. Now, you know how with an exponential equation, our domain was unrestricted? Remember that? We could put anything we wanted for x in the exponent, and the range was from 0 to infinity. Well, because a logarithm is the inverse of an exponential, that means their domains and ranges switch. So our logarithm will have a domain non-inclusive 0 to infinity and a range that is unrestricted. Why? Because it's the inverse. X's and Y's switch. It's the inverse of an exponential, so its domains and range will be the opposite. Okay, now what I want to do here in my table is I'm going to color code my base and my of term, and then my right side of my equation. So I think I'll underline my base in red. I'm just going to underline my bases in red. You can pick whatever colors you want, you know, but just stick with the colors. I think I'll do my X's in green, and I'll do my Y's in purple. Okay, and we're going to do some conversions. I'd like to do this without having to switch colors each problem. I'd rather just write all my bases down, write all my y's down, write all my x's down. You with me? Want to do it? So I'm going to start with my red pen. I'm going to start with my bases. I'm going to bring all my bases out of the basement and write them as exponents. So B, 5, 7, 16, 2 exponents. They are now bases of an exponent. Then I'm going to pick up my pink because I'm going to make all of my y's move up to, switch sides and move up to the exponent. So that's b to the y, 5 squared, 7 to the 0, 16 to the half, and 2 to the negative 3. And I'll go with my pencil and just put in equal signs. Then I'll switch to my final color and put my x's in. So equals x equals 25 equals 1 equals 4 and equals 1/8. Then when you're done, take a look at what you've created. And tell me which column is easier on your eyes. The logarithmic column or the exponential column? Exponential, right? Especially when you start looking at this one here where it says log base 5 of 25 is 2, which means what power of 5 is 25? The second power of 5 is 25, right? 5 squared equals 25. Totally makes sense, right? So you'll find a lot of times when you're solving a log that you're not comfortable in logarithmic form, so you will convert it to exponential form so that you can just get it taken care of and you can see what you need to see. Okay? So there's that. All right. Now, let me give you a couple of exponent rules that will help you to get through solving some of your basic logarithms. So we'll go back to the rule b raised to the m power, base raised to the m power, raised to the n power, your power rule for exponents. And we know that if we raise b to the m power and then we raise it to the n power, it's the same as multiplying the powers. We use that when we're solving exponential equations. Okay? All right. Another one that we haven't used in quite a while is a fraction exponent. We've done some negative exponents, some zero exponents, some positive exponents, but we haven't seen a fraction or a rational exponent in a while, and that's supposed to be an n, not an m. So b to the 1 over n power. I need you to remember how you can transfer that into something that's friendlier to you by writing it as the nth root of b. The denominator is the root. The numerator is the power. The denominator is the root. The numerator is the power. So if I raise this to the first power, will it change anything? Will it? No. Okay, so there's that. That'll be really helpful when you're attacking some of these problems, to change it from a rational exponent to a root, because it's easier to see. Like if you have, like, for example, 9 to the half power, it might just be easier to look at it as the square root of 9. Yes? Which is more friendly to your eyes. Square root of 9, right? So you can rely on your exponent rule to help you with that. And then the other one here that we might be using is b raised to the m over n. So this is another rational exponent that will feel really uncomfortable to your eyes. We don't encounter it often, which we can write as the nth root of b raised to the m power. Again, the denominator is the root. The numerator is the power to which you're going to raise. And I always take the root before I raise the power. Well, not always, but most often. Okay? So you'll need those possibly from time to time as you're doing these problems. Okay, so let's go to example 1, where you are solving some basic logarithmic equations for y. Okay, so when I read this, I read it as, what power of 2 is 8? What power do I raise 2 to get 8? 3. Okay, so some of you are seeing it. And maybe you don't like it. It's not comfortable for your eyes. So you bring that base 2 out of the basement, and you take these two guys, and they switch sides, and you go 2 to the y power equals 8, and now it looks better to your eyes, and you can see it. Or maybe you're still like, I'm not comfortable with that. I've taught you how to write these as same base. Can I write 8 as a base 2? Yes, I can write 2 to the y equals 2 cubed. True statement. And so if my bases are the same, then my exponents are equivalent. Therefore, y equals 3. You're going to be at whatever level you are as you evaluate these problems. So put the work, the effort in that you need to put in to get to the answers. Okay, let's take a look at the next one. So I'm saying when I look at log base 5 of 1, I'm thinking to myself, what power of 5 is 1? So you're seeing it. You might not see it. So you'll say, bring the base out of the basement. So 5's coming up, and the y and the 1 are switching spots, and you're looking at it. Well, I can't make 5 a base 1, and I can't make 1 a base 5. So I have to know that 5 to the 0 equals 1, therefore y equals 1. That's one of those ones you have to know. Anything to the power of 0 equals 1 except for 0 to the power of 0. Okay, question. Y equals 0. Thank you. Thank you. You are right. 5 to the 1 equals 5. Oh my heavens. All right, last one here. You have log base 7 of 1/49 equals y. You could ask yourself, what power do I raise 7 to get 1/49? Some of you are telling me -2. Let's take a look at it. We're going to bring the 7 out of the basement, and we're going to switch the y and the 1/49. And you might see it now, or you might have to write them same base. Remember that 49 is 7 squared, right? Right? And so if I want to bring that 7 up, I would have to change its sign to a -2 power. Therefore, y equals -2. Again, you are where you are in your ability to see the answers, especially when you're dealing with negative exponents. So do the work that you need to do to get where you need to be. Okay? So base out of the basement, switch sides if you need to, use your exponent, use your same base, solving exponential equations rules. Okay? And then we have these examples. Find A. And in this situation, you'll notice here A is in the base, here A is in this second position, and here A is in the third position. And there are alternate ways to find every single answer. So use the one you see. So we're going to solve for A. So that means we're going to bring the A, the base, out of the basement, switch the 5 and the 32. Don't answer it out loud, but think to yourself, what number to the 5th power is 32? You might see it. Don't answer it. Okay? Just think. You can answer it on your paper. All right? Here's some alternative ways to solve this. I could write 32 in its base. A to the 5th, 32 I could replace with 2 to the 5th. Right? So A equals 2. I could alternative go, well, the 5th root of A to the 5th is equal to the 5th root of 32. Therefore, A equals 2, if that's what I saw. Okay, so you have alternative ways that you can work through that problem. Okay, next one. You are looking for A in the second position, so let's take the base out of the basement. So that's 9 to the negative half power equals A. Okay, there's a number of ways I could go about this. I could apply the negative exponent rule. Are you with me? So if I want to make this a positive exponent, I could write it 1 over 9 to the half power equals A, right? And then this is a rational exponent, so I could write it 1 over what root? What's the root? The square root of 9 to the first power equals A. So A equals 1 over 3. I could do that. You know what else I could do? I could plug that into the calculator. It'll give me the answer. You know, it's a good alternative, right? It's acceptable. You're allowed. Okay. There's other ways you could attack that, by the way, and still come up with the right answer. Let's look at the last one. 9 to the A power equals 3. So a couple ways I could attack this. Could I write them same base? Could I write 9 base 3? Right? So 3 squared times A equals 3 to the what power? What power is this 3? 1. So if the bases are the same, then the exponents are equivalent. Divide by 2. A equals half. Truth? Or maybe you see it, oh, well, 9 is, the square root of 9 is 3. So I could say the square root of 9 is 3. And I could see the answer. Maybe. I don't know. That depends on you. But you have alternatives. So you're just going to have to use your brain a little bit. Okay, I am going to give you one more example that I didn't put in your note page. But you do have stickies on your table. You can put it on the back or you can put it on sticky, whatever you'd like. We are going to do example 3, which is a tricky little guy. It's going to trick your eyes and make you uncomfortable. We're going to solve for x. And here's the problem. Are you ready? 2 raised to the log base 2 of 3 equals x. Don't be scared. I know it looks scary, but it's not. What kind of equation is this? Exponential or logarithmic? Yes. No, the answer is not yes. Logarithmic equations will start with the word log. Does this start with the word log? It's an exponential. Yep, this is an exponential equation. It is. You just have to not let the log that's sitting up there in the exponent mess with you. Don't let it. Don't let it complicate your life. All right, I want to solve for x. Well, this isn't feeling comfortable for me, so maybe I should convert it to a log by putting the base back in the basement and switching things back around. You with me? I'm going to underline some things. So let's see. I'm going to do this one in red. So I'm going to do my base in red. I'm going to do my exponent in green. And I'm going to do my other side in purple. Just so you have it. Relax, people. This is not a big deal. You're going to, when you see it, you're going to go, oh, okay. I hope. Let's convert it to a log. So if I'm going to write it as a log, I've got to write log. And I got to put the base back in the basement. So what's going down here? What's my base? 2. And these two guys have to switch. So I'm going to put the x right here. Equals, and this guy over here that I did in green has to switch to the other side. Log base 2 of 3. What's x? 3. It's staring at you. Log base 2 of x is the same as log base 2 of 3. Therefore, x equals 3. Right here. There they are. So sometimes it's easier to see it when you write it as a log. Most of the time it's easier to see when you write it as an exponential, but sometimes you got to switch things up. Okay? So your assignment today is to do problems 17 through 63 odd. That might seem like not a lot. I think it's about 25 problems. You need practice. Lots of practice to tattoo this on your brain. Extra credit opportunities coming at you, 1 through 7 and 18 through 64 even. That's lots of extra credit. I think that could get you up to about 57 points or so, maybe more. I don't know. I didn't count exactly. But there you go. And you have 10 minutes. I bet you could get most of it done. Off you go.